So in this problem, we know that the projectile was launched at 45 degrees and it stayed in the air for 4 seconds. So we are going to work from that. Okay, and let's draw a little picture here. We got 45 degrees, and we know it makes a right angle. Okay, so if it stayed in the air for 4 seconds, we can find the initial upwards velocity of the y component, because as it goes up, we know that the apex will be at 2 seconds, and then, because it will be 2 up and then 2 down, so we know if gravity is putting -10 down on it, so if it starts at 20, then it will be 10 meters per second after 1 second, and then 0 meters per second after 2 seconds, because it is being forced down with 10 meters per second. So therefore we know the upwards initial velocity is 20 meters per second. And then since it's a 45 degree triangle, we know that this side is also 20 meters per second. And then therefore we know that this initial velocity is 20√2 meters per second. So now, if we want to find the if we want to find the maximum height of the ball, we know that we can use our handy equation of v squared. So if we want to find, we know the velocity at the maximum height is going to be 0 because it has no upwards velocity anymore. So 0 squared is just 0. And then we also know the initial velocity because it's v0 squared. So that will end up being 20 squared plus 2 gravity force, which we'll just use -10, and then the change of x, which we really care about, because that will show us the maximum height that it took. So now to solve this, we know that 0 is going to be equal to 20 squared, which equals 400, plus -20 delta change in x. So now 0 minus 400 is -400 equals to -20 delta x. So now we just divide by -20, so -400 over -20 is equal to delta of x. So that is going to be equal to 20 meters is equal to change of x, which is the maximum height it reaches.